Hi, welcome to Chili's. Today, we're going to learn about your favorite unit in your entire math career, inverses. Now, in its simplest terms, if you go back and think about it, an inverse function is basically whenever you take the x value and you substitute it for the y value, or vice versa. Now, if you think back to your pre-cal days, you might have had a function that looks like this. In order to find the inverse of this function, you flip both the x and y values. So initially, your function looks like this. Next, you cube root both sides, and these two cancel out, so you are left with y inverse equals the cube root of x. But if you recall, you're in calculus now, so you get big boy problems such as the inverse of cosine square root of 2 over 2. Now, if you're like, oh, can you see it? I'm sorry. Now, if you're like me, you probably don't remember what any of this means. So, generally what this question is asking, it is giving you an x coordinate, and you're trying to find an angle. So in order to solve this problem, you have to refer back to your nifty old friend, the unit circle. Inverse cosine is referring to x values, and you are given square root of 2 over 2. So you find where square root of 2 over 2 is the x value on the unit circle, and that is at pi over 4. So that makes pi over 4 your answer. Okay, class, so are there any questions so far? Yes, Daniel Warren. He's having one of his coughing fits again.
Don't certain trig functions apply to certain quadrants?
Why, yes they do, Daniel. So, inverse sine, inverse cosecant, both of these functions pertain to quadrants 1 and 4. Inverse secant inverse cosine and inverse cotangent all pertain to now you actually can't see. This isn't even a joke. I didn't mean to do that. They all pertain to quadrants 1 and 2. And that just leaves inverse tangent to pertain to quadrants 1 and 4. Now, you may be asking yourself, why are functions such as inverse sine restricted to only quadrants 1 and 4? Well, that is because if you plugged in a certain x-coordinate for this function, you would have two x values. And a function having two x values doesn't classify it as a function.
But wait, isn't the inverse sine positive in the fourth quadrant?
No, Mason, you can't just make up math.
Aw, shucks.
Okay, so take this problem for example. Inverse sine of cosine at 3 pi over 4. You want to do what's inside the parentheses first. So cosine at 3 pi over 4 is negative square root of 2 over 2. And that leaves you with y equals inverse sine of negative square root of 2 over 2. However, if you look at your unit circle, there are two values that yield that. But inverse sine is restricted to quadrants 1 and 4. So you would go with 7 pi over 4. However, inverse sine at quadrant 4 is negative. So you take negative pi over 4, and that is your answer. There's also inverse trig derivatives. Have fun memorizing those. Alrighty, so let's find some derivatives. If you recall, by your amazing memory, this is your equation for finding specifically inverse sine derivatives. So this is your u. You plug this into your equation. So you get 1 over 1 minus 4x squared plus x squared all over a square root, or under a square root, I guess. And then you take the derivative of u. So you're left with 8x plus 1. And that's your answer. Simple as that, folks.